Welcome everyone to Macrofab's webinar today. Today we're talking about how to maximize PCBA design efficiency with reduced redesign. Our panelists today are Francisco Luna and Cody Enlick. Cody, if you want to go ahead and let us know a little bit about yourself, that would be great.
Sure. Good afternoon, everyone. I'm Cody Enlick. I've been with Macrofab for a little over 2 years, heading strategic sourcing. I come from electronic components industry for about 10 years, a U.S. Army veteran, and that's what I do.
Francisco, do you want to let us know a little bit about yourself next?
Sure. Francisco Luna. I am actually a manufacturing engineer. I have been with the electronics industry now for about 25 years. I worked with an international company that dealt with multinational factories at different locations, including Asia and Europe. And obviously, we had those customers that also kind of were from those different areas, and obviously people from North America. I've been with Macrofab now going on 2 years, so I've been around here a little bit less than Cody, but yeah, we've known each other since I started. And yeah, I've dealt with different industries: automotive, medical, industrial controls, and yeah, I'm glad to help out here.
Awesome. I'm going to let y'all go ahead and get started on the agenda, and we will.
Yeah, so we're going to go over again the current state of things and how things are being designed today. We're going to talk a little bit about reducing time waste, managing the costs associated with the design, how to avoid counterfeit components, which is Cody's favorite topic here, and then we'll just step back a little bit and then talk about key takeaways and what kind of summarize what we're talking about here and how we kind of can best help out engineers and their designs. So again, everybody has heard this, right? It can be done fast, it can be done cheaply, or it can be done well. Pick any two. Obviously, we all strive for all three, but generally there's some kind of a sacrifice of some sort, depending on what you're looking at. And we have to work with folks to kind of work on their design to really keep in mind what they really need to strive for and what is most important. There's just no way around getting your priorities straight, whether it's dollars for the design, whether it's how quickly you want to get to market, or obviously there's maybe industry standards that actually will only permit you to do it a certain way, and it has to be done according to those standards. And that's kind of what we're talking about here, to try and make sure we optimize for that one goal initially, and then obviously work the other two in there. So let's get right in there. Again, so reducing time waste. Some of the common causes of time waste is flawed design practices. I'm talking about where a company may not have a good revision control, good engineering change order process control, where they're not following the best practices for the industry. In other words, there may be some standards industry uses, whether it's automotive, medical, even industrial controls. You can talk about IPC standards, and people will kind of go away from that, and all those will eventually catch up to you in the sense that those flawed design practices will either cause your time to market to be extended out because somebody cannot manufacture according to your design, or maybe you've designed into your bill of material and end of life components. You know very well how that works, right? Where you all of a sudden see a bill of material that wasn't scrubbed by the time the engineer released it, and actually now it's time to manufacture. Guess what? It's no longer available, or it's end of life. Maybe it's a last time buy, and now you're forced to say, well, what am I going to do with this quantity that is only available out there, and I need to already start working on a redesign. So again, you want to follow your best design practices and keep that in mind when you in your design work, to be able to avoid time wasted in the future. Maybe don't take shortcuts. It's eventually going to catch up to you. The other thing is lack of communication. Revision control is part of that communication. We talked about how we're trying to make sure that you have the latest and greatest design, and whenever you communicate that back out to the world, whether it's to a colleague that's also collaborating with your design, or whether it's a CM, you want to make sure you're always communicating the latest and greatest information. How do you do that? By revision control. You want to have a collaboration as well. Sometimes the design engineer for the electronics is not the same as the design engineer for the mechanicals. and then there may be a project lead over the whole thing. And you want to have that collaboration, communication constantly going on there. One way to do it now great is the platform with that is maybe a cloud-based platform where you can actually have everybody kind of looking at the same design at the same time. That is such a great tool for collaboration. There's no more of this handing paperwork over, sending email stuff out. There's a cloud that's actually out there where everybody can collaborate on the same design in real time. You're actually seeing what everybody else is seeing. The last thing, again, a really common cause of wasted time is long lead time for components. A bill of material can be sent out where it's the design has been thoroughly validated and everything is good, but at some point somebody did not take into account supply chain. Right?
Sure.
And supply chain is such a critical portion of what we do on a day-to-day basis today. I mean, it's everybody talks about it now, and it's in in everybody's right in front of them, right, all the time, where everybody's talking about it. And then there's a reason for that. It does lead to long lead times. We're talking about some manufacturing suppliers will go out there and tell you, some components are 52 weeks out, or longer. Anything that's longer than a year, it's basically the supplier telling you, I don't know when it's going to get here, right? My manufacturing plant back in Asia may not give me a firm date, so I just put a placeholder there until I can find out or get a real time frame. So if you don't watch out for your bill of materials lead times, that can be a tremendous amount of time wasted. That all kinds of planning that goes on with marketing and release of a design will be forgot if you don't take into account the lead times of the components. And you have to get that in real time. This industry is ever changing, right? You've seen where, in the morning you see components available, and then all of a sudden the afternoon you go out there and buy it, and it's gone. It's that dynamic. So again, going back to somebody that provides you real-time analysis of material availability is great to have. There's so many tools out there available to you now where you can actually get some real-time availability of components and their lead times. What's out there, who has it, and how long is it going to take you to buy some more. It's the information is out there. You have to use it before you actually release the design.
100%, Francisco. And if I may, while we're talking about just quickly the lead time parts, that kind of goes back to lack of communication. The strength of communication between you and your provider, contract manufacturer, supplier is really important. And especially in a climate when there is so much volatility surrounding electronic components, having a good idea of your forecast and estimated annual usage in order to secure some of those volatile parts prior to it becoming an issue has been a really big key player for some of our customers as well, which goes back to that communication.
Yeah, so. I can see that. I can see that. So going on to other ways to reduce time waste. Sorry, go back one time, Veronica. Yeah. So again, design rules checks. That's a really critical area as well. So in addition to the bill of materials we're talking about now, the actual design, you want to make sure that your contract manufacturer does some kind of a design for manufacturability review on your board, especially if it's not a mature product that hasn't been out in the field or hasn't been tested yet. There's software out there where you can actually get instantaneous feedback whether or not you're actually following this industry standard or manufacturing standards on your design itself to allow you for a quick release. Once you actually release the design, you feel confident that you've actually followed through with the proper layer thicknesses and copper weights on your board design. All your traces and everything else is according to industry standards. Your pads and your pad designs are according to component manufacturing standards. So that's one key area where you won't have your design coming back after engineering questions are published saying, hey, what are we going to do here? Because this doesn't work for us. Our manufacturing process cannot manufacture according to your design. So that's all part of the thorough design review process that you have to go through before you actually release it and send it out to any contract manufacturer. And part of that is using a cross-functional team. You want to make sure you actually work with the different folks around in your area. You talk about your mechanical engineers, your electrical engineers. Everybody has to collaborate to be able to go ahead and get your design robust enough for release out to a contract manufacturer or even an internal design if you're doing prototypes. You want to make sure everybody has had some kind of input to collaborate on that design, and you're going to get it right the first time. So again, managing costs. So the next thing is we want to go ahead and look at the actual costs to be able to kind of get your design out to the world. So one of those things you can do is optimize your PCBA for layout to reduce overall PCBA area. Generally, the tendency is to actually do very high density boards, but it doesn't always mean that it's going to be cheaper. So one thing is not to always go smaller, cheaper. It's to actually go to the right size for the product you're dealing with. Okay, so maybe the PC board itself, you're actually using S area, but now you're actually using maybe some smaller components, 0201 components versus 0603 components, or maybe some of the other more readily available component sizes, and that can actually cause you some issues there as far as cost is concerned. It can be a cost as far as the component material is concerned, and manufacturing. Somebody that has to have specialized equipment to be able to put down those smaller components may end up costing you more than somebody that has just a regular industry standard equipment without having to deal with specialized processes. And again, we talked about this, about the CMs doing design review checks. So you want to make sure you deal with somebody that's going through your design and saying, hey, you know, this is not an industry standard. The minute you kind of talk about something that's custom made, something that is not according to industry standards, it's going to translate over to cost. You know, the minute you kind of get out of the main lane where everybody else is at, you start adding costs with that. Okay. Then consider how SMT and play through whole component cost and the associated labor that goes along with that. So you want to make sure that you follow industry standards. You make sure that you don't start maybe using some hard to find components, some play through whole components that are maybe just one single sort. You have something that's only coming from one place, one geographic area, or one manufacturer. That's one way to kind of work yourself into a corner where then you're prone to higher costs. You know, you've seen this.
100%, Francisco. I would always recommend keeping a finite eye on your current bill of materials in terms of product life cycle, right? And part life cycle. A lot of times there aren't mass alerts from the manufacturers that maybe a part is going end of life. So it's always beneficial to have a partner that is on top of that in terms of manufacturability for the future.
Yeah, and I've seen it where maybe the end of life notice goes out to current users, right? But exactly. not to future users sometimes. So, exactly. So since we are actually in MacroFab, we actually have multiple projects ongoing all the time. We get those on a regular basis, but I have seen some customers where they come back and say, you know, I didn't know that was going to be end of life. It's a surprise to me. So it's great that we actually get on those notices on a regular basis, and we can provide feedback to say, hey, guess what? You definitely don't want to use that component. I've gotten notice that, you know, absolutely, after June, you know, you're not going to be able to get it anymore. Exactly. And then you're stuck with trying to redesign something or find an alternate, which can be just as difficult sometimes. Sure. Mm-hmm. So again, do we want to follow these strategies to be profitable and actually improve your competitiveness there on your design, and make sure that your design is robust enough for the market you're looking for. And obviously, everybody is very conscious about the costs. Counterfeit components, your favorite subject there.
It is. So when we talk about counterfeit components, this is nothing new. This is obviously something that has existed for many, many years. It's only recently highlighted because of this massive shortage we've been in for the past couple of years. But when we discuss reliability issues and liabilities, counterfeit components has got to be at the top of the list for many OEMs and CMs. Mm-hmm. And the main issue is mitigating those risks in a market that is flooded with suppliers and vendors in the United States and overseas that are supplying this material into the market. So the way that we have combated that internally in our prescribed method for avoiding counterfeit components is first and foremost reliability in your suppliers. So that goes with utilizing specific suppliers that have certifications that speak to their quality processes, ISO certifications, ITAR registrations, AS 9120, AS 6081, finding a supplier that is certified in your specific vertical. So if you are a medical devices company, it would obviously make sense to partner with someone who has that AS 6081 or AS 60, that required certification that yields to your specific vertical. Testing components is obviously a key strategy. That is just a daily function for us. And we test on a very wide scale, everything from basic visual inspection to acetone swiping for counterfeit detection, through decapsulization, X-raying, solderability, all the way up into fully functional testing, so that we can make sure that the parts are new and original and will conform to fit, form, and function based on the customer's designs. So when you can strengthen your sourcing process, when you can utilize testing processes to mitigate those quality concerns, you can just get positioned, you're more in a position to own a lot of your supply chain, and that really mitigates a lot of the counterfeit components entering into your production through first safeguarded with, again, tested, vetted, and certified suppliers, a partnership with a testing laboratory, whether that's in the United States or overseas, that has the ability to test those parts for counterfeit detection, and also safeguarding yourself with perhaps a partner that offers escrow services, so that there's never any financial liabilities dealing with a newer supplier. A lot of times we see a lot of hesitancy to place orders because the suppliers are asking for funds up front. Hey, we have all those 20,000 pieces that nobody else does, and we'll sell them to you, but we really need TT in advance and we need money wired. We circumvent that process by utilizing escrow services provided to us by ERAI. We are members of ERAI. Short plug for ERAI. They're somewhat of a unspoken supreme authority in the industry as far as regulating counterfeit products and components and the circulation of counterfeit components in the global marketplace. So
I'm sure you have some horror stories there about what people have tried to do to kind of, put a fast one there.
Well, it's funny that you bring that up. It's actually interesting because as we've seen the counterfeit market grow as well, the sophistication has grown synonymously, right? So a lot of times it is easy to spot the counterfeits, the fakes, and sometimes the system will actually the test will actually show the results that the part is not new and original. Say it's a Toshiba part, but it in fact outperforms the originally manufactured from Toshiba. And so it's a wide scale. There's no length, no expense spared. There's no lengths that they won't go to try and fool the market.
So these are not mom and pop shops that are kind of doing this, right? With a little, antiquated kind of system. These are very sophisticated groups.
Extremely organized.
Organized, dedicated, and actually just that's what they're doing every day. Huh?
Yeah, you can, there's a lot of companies actually, in the Shenzhen and the Hong Kong areas that are designated specifically to creating manufacturer labels, remarking, resurfacing parts. So yes, it is definitely
very sophisticated. Wow.
Big issue.
I'm glad to have you on our team.
Yeah, absolutely.
So again, in conclusion here, we've talked a little bit about the best ways to kind of optimize your design to go ahead and get it quickly to market and make sure you have you don't have these different iterations of having to go back and forth between design and manufacturing. And then we've talked a little bit about the try and minimize your costs, and all that kind of led up to this discussion about counterfeit components and what to do to mitigate the risk out there, right? Because there's risk. I'm sure everybody's kind of been at least once, but there's some certain things you can do to try and do that. So yeah, well, I don't know if there's anything else we feel from your side. If not, we'll open it up to questions. I don't know, Veronica, did you get any questions that we want to maybe address here before we sign off? We can't hear you, Veronica.
How many times have people heard that? You're on mute. If anyone has any questions, please put them in the Q&A and we can get Francisco and Cody to answer them. We have a few more minutes before we hit our 30-minute time, so we have time for questions, anyone?
Oh, wait, any horror stories there on the specifically? Have you found some counterfeit, some actual, where it actually stopped? You stopped something on the way in?
So yes, in past experiences, I definitely have come across a lot of it. I've heard of it affecting my customers as well. I think this is actually probably a good opportunity, perhaps as a cheeky macrofab plug, to just notice that we actually are running a 0% counterfeit component failure rate here at Macrofab, which is a statistic that we tout rather proudly.
Yeah, not everybody can say that. I know that for a fact. Yeah.
Yeah, and it's definitely following these processes and procedures that have put us in a position to have that safeguard.
So it's all about risk management and really kind of getting the tools in place to avoid that.
Absolutely.
Hi, guys. We have a couple of questions. First, Stephen asks, does Macrofab have default stack-ups to design around?
Yes, we do. If you go to the actual Macrofab platform, we'll actually provide you with some standards on the stack-ups. We can actually go up to typically 16 layers right off the platform. And then you can actually dictate what the layers look like and whatever pre-preg you may end up choosing, things like that. However many ounces of copper. The standards are obviously 1 ounce, 2 ounce copper. If you do have to have a custom stack up that's beyond what the platform states as a standard, we actually do have custom quoting as well. So we can actually go that route. We will assign an account executive for you, and you can at that point send us your custom board, and we'll work with you to go ahead and get that quoted. Obviously, following still the same design rule checks that we do for the platform for everybody else. We'll still do the order review and just as if it was a platform, but we have this other way of kind of massaging these other custom designs into the platform to be able to accommodate that.
We have another question from Donovan. The slideshow showed alternative components. How's that handled in Macrofab system, specifically the case of different footprint options as opposed to same package alternatives?
Yeah, so it's one of the things we added to the platform here a few months back is the additional alternates on there. You can actually state what your bill of material is, and the original preferred component is on there, but then you can actually open that lineup on the platform, and you can actually search live for alternate components, and you can actually bring up alternate components that are exactly a direct fit drop-in replacements for that. If for some reason that is not available or that is gone, it's no longer feasible, meaning that you only have that one component and that's it, you may have to talk about a different footprint. So at that point, we would have to fall back on the design folks and say, hey, this component is no longer available. We'll provide communication back to the customer saying this is no longer available. Here's the lead time for those components. And we'll work with them to try and see if we can get creative on what we can do, including maybe a different size components, different footprint. I have actually had some customers, well, they actually will design 2 different microchips with different footprints right on the board, and they'll specify, here's my preferred, and here's the alternate, and the same location, but just different footprints. And we can accommodate that as well. Again, it's all about communication back and forth. We want to be like an extension of your manufacturing. And we'll communicate back to design to say, hey, let's figure this out. So let's try and get something going and make sure that we can get your design built.
We have another question. Are the Chinese selling original parts they make from the majors direct to the market? So these parts would be identical to the original parts, kind of what you were talking about earlier, Cody.
Right. So yes, absolutely. There are counterfeit parts in circulation in the market that are performing at the standard, if not in even better sometimes. And yes, that is a true story that we dealt with a Toshiba part, not here at Macrofab, but in the past that was sent to Toshiba, and Toshiba did confirm that the part was actually not manufactured by them. However, when they tested the part in a functionality testing, it outperformed the part that they were manufacturing. It's a very few and far between case. A lot of times we're seeing dead membranes inside of the parts that are just gutless. They're inoperable. And so aesthetically, they are, they appear to be new and original until they're soldered onto a board.
Yeah. So no accusations here, but maybe it's beyond the group. Sometimes it's almost a systemic a place, maybe in certain parts of Asia, where it's kind of lend themselves to actually just put things out there, and the state, it's almost like a state-sponsored kind of a system where they actually allow those companies to operate that way. So that is a big danger. And again, another case for nearshoring, right? And try and get as much of manufacturing of components done here in North America, or where we're going to be using it.
Yeah, it really speaks to having a trusted partner on the testing lab that's boots on the ground there in Asia. The testing facility that we're partnered with, specifically in Macrofab's case, is the largest in Shenzhen in Hong Kong. Absolutely no parts leave Asia unless they've been tested.
Okay.
And so that's kind of how, again, we can mitigate that risk on the front end, so it doesn't become an issue when we receive parts and we're obviously in production and running into issues there.
And then, do you have any guidance of where to go for folks to order to avoid counterfeit components? Specifically, this person's asking about DigiKey, but do you have any other suggestions about places folks can go that are a good place to be safe from avoiding counterfeits?
I do, and really, honestly, the easiest way to answer this is just to rely heavily on suppliers that are authorized or franchised. Everyone is aware of the DigiKeys and the Mausers and the Arrows and the Avnets of the world. Well, I would tie yourself very heavily to those suppliers, and I would avoid, for lack of a better phrase, reinventing the wheel on your own. Trying to find a partner somewhat as similar to a Macrofab, if you will, that has that already as a service built in, so that they know who to go to. It can be a very, very scary and dangerous place to operate the open market, quote unquote, which is any distributor that's not authorized or franchised. And I have seen this a lot more than I have counterfeit components, which is customers will come to us with a solution, a supplier that they've found on their own. And the reason that these suppliers, be weary of suppliers who are claiming to have stock when no one else is, right?
Okay.
That's the number one kind of telltale sign, is suppliers that are showing or telling you that they have aggressive amounts of stock when the global market is saying otherwise. Again, positioning yourself with a trusted partner that is tapped into the supply chain world, that can give you a little bit more insight as to how those parts are traveling, where those parts are actually coming from, to give yourself a little bit more warm and fuzzy.
So you kind of go like levels, right? That kind of manufacturer, then authorized distributors, because some manufacturers don't sell directly to customers, right?
Sure.
Yeah, and then eventually you get down into the gray areas of the brokers and iffy parts. Okay, I see what you mean.
So it's an understanding, and it's an educating yourself really of where parts actually come from and how do they move about the world before you actually jump in to try to start just kind of sourcing them, from different places across the globe.
What do you think about customers kind of going out and buying their own parts first to try and ensure their supply chain?
Yeah, so I mean, the best advice I can obviously offer is, if you have any type of, however strong your forecasting is into your future production, and as much as you can shore up your estimated annual usage for those necessary components, dig into that as much as you can. Get really finite into, like I said earlier, the life cycles of those components. If you notice that some of the components that you're going to use in your production, maybe they're in stock right now at DigiKey, but they're not in stock at levels that you feel comfortable placing an order or relying on for future production. Perhaps it does behoove you to purchase that material in bulk, and whether you can warehouse that yourself or strategize with a partner that offers VMI or vendor managed inventory. Either one of those options is going to put you in a better position to avoid that down the road.
Good.
So we seem to be at time. I'm going to give out one more, any questions to see if anyone else has anything for y'all. But we will go ahead and thank everyone if we don't see another question. So thanks for attending. Watch your emails for a special offer for $250 off your next order with Macrofab. Any questions?
It's been great. Thank you.
Yes, thank you everyone for attending, and we will see you next time. Also, if you happen to be in the Houston area, we are having an event on May 4th. If you go to our website, you'll be able to see it's May the Fab Be With You. So we're going to celebrate Star Wars, and you also get to take tours of our new factory space. So check out our website so you can get that information. And again, thanks for attending. Thanks. Bye.
See you there.
Thanks, everybody.